Take a look at a massive cargo ship docked at port. Its voyage across the ocean is paused. The hull sits motionless in the water, towering over the concrete quay. And yet, if you listen closely, the vessel is far from silent. A deep, continuous vibration hums through the steel, and a faint haze of exhaust drifts from the funnel. It raises a simple mechanical question. Why does a machine that is no longer moving continue to burn fuel? The answer is that a stationary ship is not an inactive ship. It remains an industrial system in suspended motion. While the main propulsion engine is shut down at berth, deep inside the hull, a network of auxiliary diesel generators continues to run. Those generators produce high concentrations of nitrogen oxides, sulfur oxides, and fine particulate matter. Because the ship is docked, those emissions are released directly into dense coastal infrastructure, right beside workers, roads, and neighborhoods. While attention often focuses on trucks and factories, stationary cargo vessels are a major continuous source of air pollution at the edge of modern port cities. To understand why a docked ship keeps its engines running, you have to look inside the engine room and understand the ship as a floating microgrid. Ships are built to survive the open ocean. Out there, relying on an external power source is impossible. Everything from life support systems to navigation must be generated on board. That self-sufficiency is built into the ship's architecture, and it remains in place even after the vessel reaches land. When a large cargo ship docks, it still functions like an isolated floating power plant. And keeping that floating power plant alive requires an immense amount of electricity. First, there is the constant baseline load: navigation systems, safety monitoring, communications, deck lighting, and control equipment. Then comes one of the largest power demands on board, what the industry calls reefers. These are refrigerated containers stacked across the ship, each requiring uninterrupted electricity to maintain strict temperature control. Even a brief loss of power could spoil millions of dollars worth of perishable cargo. On top of that, heavy mechanical systems continue operating around the clock. Pumps cycle continuously to regulate fluids. Large ventilation fans pull air through lower compartments. Critical support systems remain active the entire time. Feeding all of those systems at once requires enormous power, with thermal control often taking the largest share. Without that constant supply, failures begin to cascade. Pumps stop, temperatures rise, cargo deteriorates. Vital onboard systems begin to fail. Constant electrical power is not optional. It is a structural requirement. And because those internal systems cannot simply be turned off, the only way to stop the auxiliary engines from burning fuel is to change the source of the electricity itself. That is where a system known as cold ironing comes in. Cold ironing bypasses the ship's internal generators by connecting the vessel directly to the land-based power grid. Making that possible requires serious shoreside engineering. Ports must install dedicated substations, high-voltage equipment, and advanced cable management systems directly on the quay. When a ship arrives, technicians maneuver thick, high-voltage cables out to the vessel, creating a physical electrical bridge between land and sea. Specialized panels on board receive that shore power safely and route it into the ship's distribution system. Through this single connection, a maritime structure designed for total independence becomes temporarily a consumer of the terrestrial grid. Once the electrical load has been safely transferred, the ship's auxiliary generators can finally spin down. The low-frequency rumble stops. The haze above the funnel begins to disappear. Inside the hull, nothing essential changes. The reefers continue running. The pumps remain active. The safety systems stay stable. The difference is that they are now powered entirely from shore. That is the real value of shore power. It removes the need for ships to idle at the dock, and in doing so, it allows heavy global commerce and local environmental health to coexist in the same space.